Hello and welcome to Unit 4, Lecture 2 on volcanoes. We're going to jump right into it. So volcanoes are powerful. This first bullet point says that they even compare to the explosion of an atomic bomb. The cause of many of these eruptions are the movement of the tectonic plates. Okay, so when you get one plate sort of maybe moving away from another plate, often that gives rise to the release of pressure and gas and magma in a volcano. The movement of these plates is driven by Earth's internal heat. So remember those convection currents, right, where warm rock rises, cool rock falls down. Well, if you think about the Earth, the center of the Earth, that core is warm, that outer core is very warm, and that warms up some rock, making it less dense. And then as it cools, it falls back down. That's that convection cell, just a quick review. When rock melts, it's called magma. So magma is liquid rock produced under the Earth's surface. Magma can form when three things happen, or under three conditions, okay? The first, the temperature of the rock rises above the melting point the minerals in the rock are composed of, the rock will melt, okay? So just like ice melts above 32 degrees Fahrenheit or 0 degrees Celsius, rock has a melting point too. So rock will melt at a much higher temperature, obviously, but it will melt and it becomes a liquid. Really, virtually any matter can become a liquid. Second, rock melts when there's excessive pressure is removed from the rock that's above its melting point, okay? So when you've got some rock and there's a great deal of other mass on top of that, right, and there's a sudden shift, that can cause that rock to melt. Third, the addition of fluids such as water may decrease the melting point of some minerals in the rock and cause that rock to melt, right? So when we add in a little liquid water into that liquid water makes it easier for it to melt, right? So if you've ever added salt to a pot of boiling water, it makes the water boil a little faster. It lowers that that boiling point. Same thing with this. So water sort of increases its rate of melting. What is volcanism? Volcanism, by definition, is any activity that includes the movement of magma toward or onto the Earth's surface, okay? So anytime you've got magma moving up, whether it breaks through in a volcano and flows out or not, that's volcanism. It's not quite the study of volcanoes, it's the study of the movement of magma to the Earth's surface. Now, we already talked about magma. Lava is something different, so you really have to know the difference here. Lava is magma that flows on the Earth's surface, okay? It's rock that forms when lava cools and solidifies, okay? It's also known as that as well. So lava is magma on the surface. It doesn't become lava until it breaks through to the surface. A volcano there's a missing word there, is a vent or fissure in the Earth's surface through which magma and gases are expelled. So that classic cone shape, right, that's one type of volcano. The volcano itself is what allows the magma to get through and to spill out onto the Earth's surface, okay? So it's that vent. It's kind of like a hole popped into the water balloon, right, where the water escapes through that hole. Technically, that little hole is the volcano. Magma rises upward through the crust because magma is less dense than the surrounding rock. We talked about that in the previous slide, right? When you heat something up, it becomes less dense, and it wants to escape. It wants to get up and go toward that vent and escape. It's just like any other fluids. Fluids want to move to areas of low pressure. Magma is the same. All right, so there's kind of areas of the Earth where there's more volcanoes than others, right? Obviously, you live in an area, most likely watching this, in an area where there's no volcanoes, right? Especially upstate New York, where we're located here at McQuaid. There's not a volcano really in sight. Like earthquakes, most active volcanoes occur in zones near both convergent and divergent boundaries of tectonic plates. A major zone of active volcanoes encircles the Pacific Ocean, all right? This zone is known as the Ring of Fire. It's formed by the subduction plates along the Pacific coast of North America, South America, and Asia, and the islands of the South Pacific. Get to know this term, the Pacific Ring of Fire. We've already watched a little bit of a video on that in class, and we're going to talk about it more and more. So here is the Ring of Fire. You can see here these small red dots indicate areas of volcanic activity, and you can see along that Ring of Fire, look at all the red. There's red there, right there, right there. Some of these are underwater, but you can still see that entire ring of fire there. That whole, I'm going to try and use a different color pen here. This whole green area here where my pen is outlining is that ring of fire. So it's that huge area there. You can see the United States does have a little piece of it here on the west coast, along San Francisco. That's why it's seismically active. Up here in Alaska also, you can see some of the ring of fire, but some of the more famous places are along here in Hawaii. Southeast Asia has had a ton of them recently. We've talked a little bit about the tsunami in Indonesia, and that was a result of an underwater earthquake. So along with volcanoes, there's lots of earthquakes along the ring of fire too, as you may know. So this is the ring of fire. Know this. They also occur along subduction zones. So many volcanoes are located along these subduction zones where one tectonic plate moves under another. That is a review, gentlemen, and maybe ladies if you're watching this at another school. These subduction zones, as we know, is where one plate, often oceanic lithosphere, meets one that consists of continental lithosphere. The denser oceanic lithosphere moves or subducts beneath the continental lithosphere, right? So we have that one plate that's a little bit more dense is going to subduct underneath the other one, and this may move over top, right? So as this subducts, it melts. A deep trench forms. You have like this trench forming right there. There's the trench, okay? The trench forms under the ocean floor along the edge of the continent where the plate is subducted. Okay? So as that oceanic plate sinks into the asthenosphere, fluids such as water from the ocean and maybe subducting under combine with the crust and the mantle material. And remember, what does water do? Well, water decreases that melting point, right? So it speeds up melting. All right, so that water added to it helps that rock and form more magma, right? So that helps the rock melt and form magma. So we've got a lot of extra magma because of all that melted oceanic crust, all that nice, beautiful rock. All right, so some magma breaks through the crust above it and makes it to the Earth's surface. That's going to result in a volcano. That's why we see volcanoes around subduction zones. Over time, a string of volcanic mountains called an island arc can form on that plate. All right, they're usually perpendicular to the plate movement, right? So if you've got a big plate right here, and that plate is moving there, you've got islands sort of perpendicular to that, right? So that would be kind of moving in this general direction here, okay? So as more magma reaches the surface, the islands become larger and join to form one landmass, all right, such as Japan. All right, so present-day Japan is an example of an island arc. So it's a string of volcanic mountains. So essentially, Japan started out as a few volcanic mountains in the ocean, right? And what comes from volcanoes? Lava, rock, right? And that lava spews out, making the volcano even bigger and bigger and bigger and bigger. And these chain of mountains kind of connect bigger and bigger and bigger and bigger. Eventually, they become the island of Japan, all right, which is a pretty big island. Okay, you can kind of see the subduction zone here. You can kind of see how that island arc forms. So you've got the plate moving this way, the plate moving that way, and the island arc chain is kind of forming in that direction, sort of that perpendicular direction there, right? So you can kind of see the magma has come down here, it's melted. You've got magma rising up here, erupting from the volcano, it's cooling and forming rock and forming an island, okay? So a volcanic island arc, remember Japan is our example of that, all right? This is a great view of the subduction zone, so definitely study this for the quiz, study this for the test, use this as a proper example. Another instance where we see volcanoes is at mid-ocean ridges. The largest amount of magma comes to the surface where plates are moving apart at that mid-ocean ridge. Remember, so you've got a plate here, you've got a plate here, and they're moving apart, and magma comes out. There's the mid-ocean ridge. This magma erupts to form underwater volcanoes. Most volcanic eruptions that happen along a mid-ocean ridge are unnoticed by humans because they're so deep in the ocean, right? We're up here kind of hanging out, and all of these volcanoes are kind of forming way below the ocean. Okay. One other example is a hotspot. So this is different from an island arc. Okay, a hotspot is a volcanically active area of Earth's surface, commonly far from a tectonic plate boundary. So the island arc we saw before, where we were looking at Japan, happens at that convergent plate boundary, right, where the two plates are coming together. Are coming together, not going apart. Okay. Most hotspots form where there's columns of solid hot material from the deep mantle called mantle plumes that rise and reach the surface. So basically, these big pockets of magma. All right. As magma rises to the surface, it can break through the overlying crust, right? So if you have a piece of crust here, think about like a big plume, almost like a big pillow of magma down here that's going to rise and eventually break through the middle of a plate. So this is not a plate boundary. This is just along the middle of the plate. Okay. The interior of that tectonic plate. So this occurs at an interior. If you think about island arcs take place at a plate boundary. That is a difference. You have to differentiate hotspots from island arcs. Okay. However, the lithosphere still moves above it, right? So if we recreate that drawing we had before, there's the magma plume right there. There's that big pocket of magma rising up, breaking through. Well, that continental, the lithosphere, the plate, is still moving, right? They're always kind of moving a little bit. So the volcano on the surface is eventually carried away from the mantle plume. So if you think, as time passes, I'll draw that plume again. The plume is still here, forming a new volcano. But that old volcano, that old mountain, that mound that formed is still there, right? Because the plate is slowly moving. This activity of the volcano stops because the hot spot is no longer feeding it, right? So we don't have the magma here anymore feeding the old hot spot there. So it kind of becomes like a dormant volcano. The island is still there, all the rock is still there that formed from that volcano, but the plate has kind of moved on to a new place. Okay. However, a new volcano forms where the lithosphere is moved to the mantle plume in the new place. So we've got a new volcano forming here, right? So eventually we have a whole chain of these islands of these volcanoes. So that's how the Hawaiian Islands formed. Okay, they're an example of a hot spot. Okay, so as that plate keeps moving and moving and moving, it's going to create more and more islands. So there's new islands forming in Hawaii as long as that magma plume is still there to provide some of that hot magma to create a new rock. If you've ever been to Hawaii, you can see the volcanoes erupting and lava escaping on some of the newer, smaller islands. Okay, and here's an example of that here. There's the mantle plume. There's that pocket of magma in the middle of the Pacific plate. You guys can see here it's kind of erupting here. This is the island of Hawaii, which is a currently active volcano. It's just getting bigger and bigger. And here's some of these older islands, right? So if you look at MA, saying for millions of years ago, Ni'ahau, I'm sure I'm saying it wrong, right here, is 5 million years old. Kauai is also 5 million years old. But look, Oahu is 3 million years old. Molokai is 2. Maui is 1.3. So you can tell that this magma plume here was once over these islands at different times, but the plate has moved along. The plate has kind of moved along from it. Okay, so these are older. All right, so make sure you can tell the difference between a hotspot and an island arc. Make sure you know how subduction zones create volcanoes. Make sure you know how lava escapes and becomes a volcano. And then next we'll talk more about what actually happens during these eruptions and why some are so big and some are quieter. Hope you have a good night and get ready for your quiz. Take care.